Hi, today I'm going to teach you how to use the graph and perseverance calculator. First, I'm going to create a function. I'm going to create a name first. Let's call this name. Let's name this test, graph test. And I'm going to call this sine of x. And then I'm going to get variables. And x is equal to x. And solve. I'm going to go in graph. I'm going to click on add, and when you add the formula, you want the formula to be graph test, because that's the formula we want to test our function in. So here, graph test, and this is the graph of our sine function. Now, as I've mentioned in my description of the app, the graph does not the graph are slow. So if you have a slow computer, it might not work very well. So here we have point x and point y. This is where you can shift the location to a point, and then you have the resolution. I'm not going to touch that. Well, actually, I'm just going to change the resolution a bit. If you change the resolution, you can see that the lines get straighter. It's not very high definition or curvy. So that's for it's for performance. It's just to increase the performance of the graphs. And here is the zoom, the scale, and this is the size of the axis. So if you want the axis to be larger, just increase it. If you want it to be smaller, just decrease it. And then the step are if you want to increase the numbers or decrease the number of step between the axes. So for example, this is 1. You want to start at 2, then input 2. If you want to start at 3, input 3. And then the axis will start at 3, 0, 3, 6, 9 instead of 1, 2, 3. So the graphs are still slow. I'm still figuring out a way to fix it to increase the performance of the graph. So you'll see that in the official release if the graphs are fixed or not. Or if the graphs are fixed, you'll see it in the official release. But if it's not, then I might not release the official one. So let's X this out. Okay. Let's close this. Okay, this time we're going to use the functions from graph. And let's right click on this vec2. Now vec2 only works with 2D vectors. The oranges are color coded for 2D vectors. Blues are color coded for any graphs. So we're going to use time and sine. And then we're going to open up the graph. Click add. Let's add in graph test. Okay, now let's click solve here. Okay, now it doesn't do anything at first, but for time, time is actually used for animating the function. So you have to click on play. When you use time, you have to click on play, which is located here, and click on it, and here you'll see the sine wave starts to change. Now let's do it again. You can pause it, actually. You can pause it and then resume it, and that's how you check that's how you run the time on the sine wave. Now let's stop it. Now, if you want to check a value at x, if you want to check the y value at an x position, say let's press play, like a value at 1, here you see the value at 1, value of y at 1, which is constantly changing because of the animation. But if we stop it, it's at the value of y is at 0. Let's X this out, close it, see how much time I have left. Okay, now I'm going to go to my website. I have some formulas. So I have some free formulas for you guys, and I'm going to teach you how to use the evenly spaced circle. So I'm just going to copy the formula. And then paste it down here. I'm just going to give this graph 2D test. I'm just going to click on get variables. I'm just going to fill in the values, which is circular radius, degree, and INS is instance number of people. Let's say 10, and then starting number of people in a unit is going to be 1. Now I'm going to click on solve. Okay, there should be an error. That's fine. Let's click on graph 2D. Let's add in the graph test. Now, as you can see, there's a ring, a circle with, let's increase the size of the circle radius to 1 so we can see it better. Now, each circle represents a person in a unit. So if you're a game developer, each circle represents a single person in a unit, and the math behind this is to form a circle with the people in each person in a unit. And it's a perfect circle, actually, to form a perfect circle. So even if the diameter of the person changes, like from 1, the radius changes to, let's say, point 2, the circle still remains. Okay, so the formula behind this is this. So I'm going to explain what the formula is doing. So when you use the formula function, it just brings down a formula, which is this one, which is on the right side of the function, and then on the left side is the name of the formula that you're bringing into the application. And if you want to use it inside of the application, you can just use the formula name. Wait, let's right click on this. Okay, so the description says formula name and X is an expression. Replaces all formula name with an X expression. So this is expression, this is the formula name. Anywhere in the formula, if you use the name of test X, then it's automatically replaced with that expression. And when you use formula, you have to make sure that formula is used at the beginning of the formula. The formula, when you use the formula function, make sure it's used at the beginning of a formula. So you can actually have multiple formulas. In programming, there is actually another way of creating a variable, but with Mathonet. And let me check the time. Okay, so this is it for the Graph 2D, and I'm just going to close the application now. Thank you for watching.